In the previous video, we learned a very important basic idea that we can use to help us understand different kinds of forces going forward. So first, if we see that the speed of an object increases, that tells us there is a force acting in the same direction the object is moving. And if we see an object speed decrease, that tells us that there is a force acting opposite to the direction the object is moving in. So let's apply this to a simple experiment. I'm going to just toss the tennis ball up in the air, and we can see the tennis ball go up and then come back down. You can try this in your own environment. Just find an object, toss it in the air, see what happens. Okay. Now, when I do this here in my space, watching the tennis ball on its way up, I see the tennis ball going up and getting slower, right? You can pause the video and try that on your own. Take something in your vicinity, toss it upwards and see what happens. I think you're going to see it get slower as it goes up. Okay. Now, on the other hand, when the tennis ball was on the way down, I saw it getting faster. Again, this is something you can try on your own. Find an object in your own vicinity, right? Drop it. And I think you're going to see it get faster on the way down. So putting it all together with a single toss, I see the tennis ball getting slower on the way up, faster on the way down. Now let's put it together with this idea here from the previous video and see what we can learn. When the tennis ball is on the way up, it's getting slower. What does it tell us when we see an object getting slower? It tells us that there is a force acting on the object opposite the motion. So if the tennis ball is going up and getting slower, it must be experiencing a force opposite the motion, namely downward. On the other hand, when the tennis ball is going down, it's getting faster. We know that when an object is getting faster, it is experiencing a force in the direction of motion. So if an object is going down and getting faster, it's experiencing a downward force as well. Putting it all together, when the tennis ball is on the way up, getting slower, it must be experiencing a downward force. When the tennis ball is on the way down, getting faster, it must be experiencing a downward force as well. So for that entire motion up and down, the tennis ball is experiencing a downward force. Now, let me start to put this together. Okay, so I did this experiment in the Los Angeles area, about there on the globe, and I saw that there was a force acting on the tennis ball towards the surface of the Earth. In other words, in this direction right here. Okay. Now, I have also been at some point in my life to Buenos Aires. And I hope you can see Buenos Aires down there. And I remember in Buenos Aires dropping an object. And when I dropped that object, it moved towards the ground, getting faster as it moved towards the ground, which means there was a force in that direction, right? So notice these 2 points on the globe, Los Angeles, Buenos Aires. In either case, when you toss an object in the air or simply drop the object from rest, you notice there is a force acting on the object directed towards the ground in your vicinity. And perhaps you have done similar experiments of your own at different places in the world as well. Yesterday in class, there was a student who told me she had been to Tehran. Okay, so yesterday in class, there was a student who told me she had been to Tehran. And in Tehran, it turns out that if you drop an object, it moves towards the ground, getting faster as it moves towards the ground. In other words, an object in Tehran experiences a force in that direction. Now, I wish I could hold all these different pens and pencils indicating all the different directions. But I only have two hands. So I'm just going to do this using Los Angeles and Tehran. And you notice that for any of these experiments, you always get that there is a force acting on the object directed towards the center of the Earth. So you can take any object anywhere in the vicinity of the surface of the Earth, do the same experiment I just demonstrated for you with the tennis ball, and you will find that that object is experiencing a force directed towards the center of the Earth. What could be the thing exerting that force? Could it be the entire Earth? Right? So any object in the vicinity of the Earth experiences a force exerted on it by the entire Earth directed towards the center of the Earth. So any object in the vicinity of the Earth is pulled towards the center of the Earth by the Earth itself. In fact, you can take any two objects anywhere in the universe, and those two objects will exert forces on each other, which tend to pull the objects together. All of those are examples of what we call gravitational forces. So the gravitational force is an attractive force. And by that, I mean that gravitational forces tend to pull objects together. And every object in the universe exerts a gravitational force on every other object in the universe. In particular, objects near the Earth's surface are pulled towards the center of the Earth by a gravitational force exerted on that object by the entire Earth. So now I have introduced you to the first of the forces which come up over and over in this class. And in the next video, I will introduce you to the next of those forces.